All right, this is Math 209, Week 4. We are in Section 10.2. Now we're converting. All right, so this is just more practice of converting between the exponent and the radical notation. So you've got the exponent versus the radical notation. So we know you always take that base, that x, you put it inside a root, and the denominator, in this case it's a 6, always is the root number, the root that you're taking it to, and the numerator always goes inside. So anything raised to the first power is the thing itself. So this is basically the 6th root of x, and that is our answer, and we can check to see if we're right. It's like, whoa, bam, I am right. So here, they want us to change this expression into radical notation, but it's possible that we're also going to have to do some simplifying. So let's do that. So let's get over here on some scratch paper, and so you've got 12 raised to the 2/5 power. So we know that that becomes the 5th root of 12 to the 2nd power. So how do you simplify that? Well, this becomes the 5th root of, and that becomes 12 times 12, because that's what the 2nd power means, right? Now, I'm going to change both of these 12s into expanded notation. So that becomes the 5th root of, and this becomes 2 times 2 times 3 times 2 times 2 times 3. All right? And the reason I did that is I wanted to see if any factors show up 5 times. Because if something shows up 5 times, I can circle all 5 of them and cross them off and take one out. But since nothing shows up 5 times, I'm just going to multiply these all back together again, and I'm going to get the 5th root of 144, and that should be our answer. Let's see if we're right. Yeah, I am right. So you'll notice it says 5th root of 12 squared. Well, that's 144. My math lab should accept this as our answer. But to be on the safe side, what I would do is I would leave the answer in this form. So enter it that way. All right, so on this one, again, we're just taking that exponent expression and writing it as a radical notation. So when you have y to the negative 3/4 power, immediately that's going to become 1 over y to the positive 3/4 power. That's just the rule. Just 1 over, and then you take this thing and you put it down here, only now instead of it being a negative exponent, it becomes a positive exponent. And so this becomes equals 1 over, and then this becomes the 4th root of y to the 3rd power. And that is what you're going to enter into my math lab. Now you'll notice they have something a little bit different, but these are the same form, the same answer, just slightly different format. My math lab will accept both of them. So here we've got this radical notation here, and we're being asked to change it into that exponent notation. So when you've got the 6th root of t, and remember that's t to the 1st power if you don't see an exponent, it's a 1. And so that means it's going to be t raised to the 1/6 power, and that is your answer. And let's see if let's see if we are right. Let's see, can I get that? Make that go away. I'm trying to make it go away. Go away. Send it back. Go away. There it is. Ah, there we go. And we got it. There it is. So you'll see that we got the right answer. Rockin'. So here we've got the radical, and we want to turn it into an expression with fractions as your exponents. And so I'm going to get that, and let's go over here. So we've got 1 over the 5th root of x to the 6th, all right? And so first thing we're going to do is we're going to take care of this denominator. We're going to write that as 1 over, and this becomes x to the 6th fifth power. Now technically that could be right, but we also know that we can change that to x raised to the negative 6th power. So for me as a mathematician, both of these are right. Either of those are right. So let's see, what does my math lab want? Okay, so my math lab says they're looking for this version. But really my math lab would accept either of them. They both would work if you type them in. All right, so first thing we're supposed to do is write it in radical notation. Then we're supposed to get the answer. So that first part, you're not supposed to solve it. You're just supposed to rewrite it, and that's it. So if we do that, so you've got 25 raised to the 1/2 power, and that is equal to the second root of 25 to the first power. And we don't really need that 1 there. So we really, if we wanted to, we could just write the second root of 25. But also, that 2 is assumed. So if you don't have the number there, it's assumed to be a 2. So the first thing is you can write that is your first part of the answer. And then the second part is to evaluate it. And so what is the second root of 25? And the answer is 5, because 5 times 5 is equal to 25. And so there are our answers. So we have another two-parter. We're supposed to rewrite this in radical notation, and then we're supposed to get the answer. So when we do that, so 256 raised to the 1/4 power becomes the fourth root of 256 to the first power, which really is the fourth root of 256. So that's the first part of the answer. Now the second part is to get the answer. So what we're going to do is we want to write 256 in expanded notation. So I'm going to go over here and I'm going to take 256 and I'm going to factor it using what's called a factor tree, prime factorization. So I'm going to choose 2 because the number is even, although I could choose any number that works. But 2 times what gives me 256? Well, that's 128. And then this is prime, so I'm going to circle it. But 128 is not prime, so that's 2 times 64. 2 is prime, so I'm going to circle it. Well, what's 64? Well, that's 8 times 8. Neither of those are prime, so I can't circle them, but I can factor them. So 8 is 4 times 2. 2 is prime. 4 is 2 times 2. So those are prime, so I'm going to circle them. And then I can kind of repeat that same process here for 8. That's 2 times 4. 2 is prime, so I'm going to circle it. 4 is 2 times 2. Those are prime, so I can finally circle it. So if you think about it, 256 is equal to 2 times 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 2. I should have 1, 2, 3, 4, 5, 6, 7, 8 2's being multiplied. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, so 256 is 2 to the 8th power. So I'm going to go way over here, and I'm going to change this to the fourth root of 2 times 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 2. And then using the Duane Habecker way of doing this, this 4 says we're supposed to circle 4 2's, cross them out, and write one of them outside of the root notation. And then we have another set of 4 2's, so I'm going to circle them, cross them out, and write one down. And what do we have left inside the root? Nothing. Nothing is there. So that whole thing goes away, And so our answer is 4, because 2 times 2 is 4. And that is the second. Oops, what is that? That is the second part of your answer. So if we wanted to check, it would work out. All right, another two-parter. First we have to write it in radical notation, and then we have to simplify. So let's scooch over here, and you've got negative 125 being raised to the, and of course I forgot it, 2/3 power. Raised to the 2/3 power. So that really means, in radical notation, the third root of negative 125 raised to the second power. Now there's more that we could have done to simplify this, but this right here is what my math lab is looking for in that first part. So the second part is asking us to simplify it. So let's simplify it. So it's the third root of negative 125 squared. All right, and so we know that this answer is going to be, well, let's simplify the inside. So that's the third root of, and this is going to be 125 times 125. Now we know the answer is going to be positive because a negative times a negative is a positive. So this really becomes the same thing as 125 times 125. And now I'm going to write both of these numbers in expanded notation, and I happen to know that 125 is 5 times 5 times 5, and then this is times another 5 times 5 times 5. All right, so this 3 5s comes from this 125, these 3 5s come from this 125, and then since the exponent is, or the root is a 3, we know we can circle 3 5s and write one of them down. And then we can circle another 3 5s, cross them out, and write one of them down. And what are we left inside the root notation? Nothing. So it goes away, and our answer is 25. All right, so two-parter. First, we're going to write down 4 3/2 in radical notation. Then we're going to simplify. So in radical notation, we know that that 2, it becomes the second root of 4 raised to the third power. That's it. That's all they want us to do. They don't want us to simplify any further for the first part of the problem. Now, for the second part, they do indeed want us to simplify. So let's simplify. So what does this become? This becomes the second root of 4 times 4 times 4. Now, rather than multiplying these together, which I would get 64, a nice shortcut is to leave it broken up and actually break it up further. So this becomes 2 times 2 times 2 times 2 times 2 times 2. And now, this second root means whenever you see two numbers, you circle them, you cross them out, you write it down. You circle 2, you cross them out, you write 1 down. And then lastly, you circle 2, you cross them out, and you write 1 down. And so what's left inside the radical? Nothing. So we can just cross that whole thing off. And so we are left with 8, because 2 times 2 times 2 is 8. And so that's our answers. We could see our answers right there. All right, so we are another two-parter. First, we're going to rewrite this number in radical notation, and then we're going to simplify. So in radical notation, we know that the 4 becomes the fourth root of, oops, I need to undo all of that because I forgot that it was a negative exponent. So when it's a negative exponent, it becomes 1 over 256 to the 3/4. So notice the exponent becomes positive, and that's key. And then now we can write that as 1 over, and then it becomes the 4th root of 256 to the 3rd power. So there we go. Now, that's the first part of the My Math Lab answer. Now the second part is we have to simplify that. So it's going to be 1 over the 4th root of 256 to the 3rd power. Now this is pretty crazy. We know that 256 is 2 to the 8th power. So it becomes 1 over, and then this is going to be the 4th root of. All right, now here's the fun thing. We know that this is 256 times 256 times 256. But this 256 is really 2 times 2 times 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5, 6, 7 times 2. And we know that this 256 is really 2 times 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 2. And that this 256 is really 2 times 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 2. So this is really, inside, this is really 2 to the 24th power. All right, so we can continue simplifying this. So this 4 means if you see 4 2's, you circle them, you cross them out, and you write a 2 outside. All right, so, oops, except I need to remember that this is all supposed to be 1 over the 4th root of, and then this is 24 2's. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. All right. And so, continuing, this is equals 1 over. Now, I get to start circling things. So 4 2's means I can circle 4 2's, cross them out, and write 1 down. I can circle 4 2's, cross them out, and write 1 down. Circle 4 2's, cross them out, write 1 down. Circle 4 2's, cross them out, write 1 down. Circle 4 2's, cross them out, write 1 down. Circle 4 2's, cross them out, write 1 down. Do we have anything left over inside the radical notation? Nope, so I can ignore it. And so all of these 2's are being multiplied. And so we end up with 1 over, goodness gracious, 2 times 2 times 2 times 2. That's 16 times 2 times 2 is 4. So that's 1 over 64. Oh my goodness, that's a lot of 2's, and that's a lot of work. Let's see if we're right. And sure enough, yep, we're right on both counts. 1 over 64 is the answer for all that work that we've just been doing. Look at all that. That's pretty awesome.